So good afternoon. Today we're going to see this topic about non-ideal characteristics. This is related to the subject VLSI design. So this is one of the topic that comes under the mass transistor principle. So here, here the non-ideal IV characteristics will hold the following ideal characteristics, non-ideal characteristics. So ideal in the sense it is ideal in the sense. So in the ideal characteristics of in a MOSFET, that is ideal means the transistor is in the off condition. So that is the ideal characteristics. Whereas in the non-ideal characteristics means it deals with the transistor which is in on condition. So here it deals with six to seven characteristics, that is the non-ideal IV characteristics. So IV is nothing but the current and voltage characteristics. So in this mobility degradation, so what is this mobility degradation? So the mobility degradation that it transfers the carriers, okay, it transfers the a mass transistor consists of three terminals, that is a gate, a source and drain. The electrons get a flow from the source to drain. So that is the mobility degradation. So the while electrons moves from source to drain, it will not follow in a single path. It will use to scatter with the electrons. So the moment of the electrons in that pathway get reduced. So that particular process is called the mobility degradation. So next is the velocity saturation. So while I applying a high electric field in the VDS, that is to the drain source voltage, if I apply a high end electric field, what happens is my velocity of electrons, the moment will get stopped in a particular point. That is, it gets saturated in a particular point. That saturated point is called the velocity saturation. So if I am applying a high end of drain to source voltage, the moment of my electrons in that pathway from source to drain will give a saturation. That saturation is called the velocity saturation. So here it is defined with an equation, that is V equal to nu into double E. So nu is the mobility and E is the electron carrier. So it is also can be given by the equation VDS, the VDS divided by L. So VDS is the drain source voltage where L is the channel length. So this is the velocity saturation. So next about the body effect. So in any transistors, so for example in an IC, numerous transistors get connected. So in that particular IC, if two different transistors connected in a different criteria, so for example some transistor will directly connected to ground and some transistor will connected to the next end of the transistor. So here comes a variation in their threshold voltage. So that threshold voltage is called as the body effect. So next is drain induced barrier lowering. So here it works as an PN junction diode. So drain induced barrier voltage, it works as an PN junction diode. What happened is when I increase my VDS, that is the drain source voltage, the depletion region will form around the drain region and also the source region. So both depletion region that form around the source and the drain will meet in a particular point. That particular point is called drain induced barrier lowering. So next is this is the diagram. Here I have shown you in the depletion layer that form with the dotted lines which has formed around the source and the drain region of the given MOSFET transistor. Next is the channel length modulation. So channel length modulation is when there is an electron movement from source to drain. So the length of the channel get varies depends upon the drain voltage or the gate voltage. So the length of the channel that travels from the source and drain will get vary depends upon the drain rise of the depends upon the two main voltages, that is due to the rise in the gate voltage or due to the drain voltage is called the channel length modulation. So that particular process, that is the length of the channel get modulated means the changes that happens in the channel. So this is the channel length modulation. So next, this is the subthreshold conduction. So as the same thing as we discussed, if there is an variation in the threshold voltage of each particular transistor in an IC, so that conduction is called the subthreshold conduction. So next is the gate leakage. So if sometimes overflow of gate voltage, the voltage get passed through the silicon material or the silicon oxide, and it will get into the source and drain, will affects the flow of electrons from the source to drain. So that is the gate leakage process. So these are the non-ideal current and voltage characteristics that may happen when there is a process of an MOSFET operation in a given IC. So these are the these are the gate leakage range. So with this small assessment, we stop here and we continue about the PWEL process in the next session. Thank you.